All right, so let's now talk about rational functions. So, like rational numbers, right? Rational numbers are fractions, so rational functions will also be fractions. So, if you have a rational function, it's basically going to be some polynomial over another polynomial. So, g of x, h of x, those are both polynomials. So, it could be something like x plus 2 over 3x squared, right? It could be something like x squared plus 2x plus 1 over x minus 7, right? Could be anything. Could even be x plus 3 over 2, right? Because 2 is a polynomial. It's a constant polynomial. Good. So the domain of these are going to be real except for the zeros, of course, of the denominator. So remember, 0 is just a fancy word for the x-intercepts of the denominator. So basically, right, we know that if that's the case, then h of x can't be 0. We've talked about that before, right? Anytime you have a fraction where x is in the denominator, that can't be 0. Good. So let's talk about asymptotes. So if you have something where x cannot be in the domain, graphically speaking, what happens is either you will have a vertical asymptote, which is basically a line, right, that x can't be, or you'll have a hole. So let's talk about the easy one first, the hole. So a hole is just a missing point, right? So if you had a line, but you couldn't have an x value right there, you would just have a hole like that. So that's one way that we could get not have an x value. But like I said, another one is a vertical asymptote. So vertical asymptote is going to be a line, right? So it's going to be x equals, we'll call it a. So it's not a, it's x equals a. Don't forget that. That's super important. So basically what happens is that f of x, the y value, is either going to go to positive infinity or negative infinity as x approaches a, either from the left or the right. Right? So as x approaches, right, for your graph, when x gets closer and closer to a, the y values are going to go either all the way up to infinity or down to negative infinity. And that can be from either direction. So if it's coming from the right, it can't actually be x equals a, right? Because that we said that's not part of the domain. So then either it's going to have to go all the way up, the y values to infinity, or down to negative infinity. So how can we figure out what the vertical asymptotes and holes are? Well, we already talked about it's going to be the things on the denominator, but what's the difference between vertical asymptotes and holes, algebraically speaking? So if we let f of x equal g of x over h of x, and it can simplify down to some other polynomials. So we can say s of x over t of x. So that's an s. Ugh. Every time I try to do s's more slower, they just end up looking like 5s. This is an s. All right. So this is its lowest terms. So basically what we say is that if we have a real 0 in the simplified denominator, t of x, then the graph will have a vertical asymptote at x equals r. So after you simplify it down, we basically solve for 0, or right, let it be equal to 0, solve for x. Whatever values we have, those are going to be vertical asymptotes. Now, the way we get holes is that for any real 0 that's in the denominator of the original, but not in the simplified form. So basically, that was something that we canceled out. So if it's something that's simplified out of it, that was on the top and the bottom, what you're going to end up having is a hole. So we have a hole at r, f of r. So basically we just plug in r, that r value, back into our simplified equation to figure out where it is. Okay, there's a lot of words and symbols, so let's actually do some examples. So for this video, we're going to basically talk about 4 examples, and we're going to go through all of them. The idea is that ultimately we want to know how to graph rational functions. That's the goal for the end of this lesson. We want to know how to graph rational functions. So we're going to go step for step, learn how to do all the different stuff, and then we're going to put it all together. So you might want to save like a page for each example. That might be a good idea. All right, so vertical asymptotes. Well, notice there's no way to simplify this, right? So since there's nothing to simplify, we see that there are no holes, because holes only happen if there's a simplification. So what's left over, right? What makes x minus 4 equal to 0? Of course, it's 4. So we have a vertical asymptote at x equals 4. And we're done. That's it. Yeah, of course, it's not going to always be that easy. We can even see example number 2 for that. Woo, there we go. All right. So let's simplify all this and figure out where are the holes and where are the vertical asymptotes. So let's look at the denominator first, because we have a difference of squares, right? So that's going to be easy. That's just x plus 3, x minus 3. All right, next one. What 2 numbers multiplied gets you 6, adds gets you 7. We can see that's just 1 and 6. All right, next. What 2 numbers multiply gets you 30, adds gets you 11. Hopefully we can see that that's 5 and 6. All right, and then this last one. Well, first, notice you can take a 5 out of everything, right? So let's do that first. Let's take out a 5. So we get 5 times, oops, oh no. We might just have to pause it. It might be over. So we might have to do a part 2 of this video.